This is the Algebra 1B semester exam review for Unit 4, Topic 2, questions 38 through 52. This is the formula sheet that you're given at the beginning of your exam. Please don't forget about it as it's very important and it's got really important formulas that you will need to know to be successful. For items 38 through 43, multiply as indicated. So when I go through these problems, I'm going to do two different types of multiplication. I'm going to do the box method, which is the algebra tiles, which I've been doing throughout the review, but I'm also going to do the distributive properties so that you can see that as well. Either way works, you will not be asked to do one specific way over another, so just keep that in mind. So for 2x minus 5 times 4x plus 7, I'm going to make my box. I'm going to have 2 x's down here minus 5 and 4 x's plus 7. Well, 2x times 4x is 8x squared. 2x times 7 is 14x. Negative 5 times 4x is negative 20x. And negative 5 times 7 is negative 35. So what we get is 8x squared, 14x minus 20x, which is negative 6x, and then we have our negative 35. 3x minus 2 times x minus 9. I'm going to use the distributive property to solve this one. So really what I'm going to have, I'm going to use two different colors. What it's really going to be is 3x minus 2, 3x minus 2 times x minus 9. And when I do this, I'm going to multiply my 3x by my second binomial, and I'm going to multiply my negative 2 by the second binomial. Then I'm just going to do the distributive property. 3x times x is 3x squared. 3x times negative 9 is negative 27x. Negative 2 times x is negative 2x. And negative 2 times negative 9 is positive 18. This then simplifies to 3x squared minus 29x plus 18. So my two binomials multiply out to 3x squared minus 29x plus 18. Number 40 is 2x minus 3 squared. And we have this habit of wanting to distribute this square to each term, but that is wrong. My advice to you is always to remember, for instance, that x squared is x times x. So 2x minus 3 squared is 2x minus 3 times 2x minus 3. I can use the box method for this. I've got 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. This is going to simplify to 4x squared. Negative 6x plus negative 6x is negative 12x plus 9. For number 41, we have 5x plus 3 squared. So again, 5x plus 3 times 5x plus 3. If I want to use the distributive property, I'm going to take 5x, my first 5x, and multiply it by my second binomial. And I'm going to take my plus 3 from my first binomial and multiply it by 5x plus 3. 5x times 5x is 25x squared. 5x times 3 is 15x. 3 times 5x is 15x. And 3 times 3 is 9. So this simplifies to 25x squared plus 30x plus 9. So our answer is going to be 25x squared plus 30x plus 9. Next we have x plus 7 times x minus 7. So if I make my box, I've got x plus 7 times x minus 7. X times x is x squared. X times negative 7 is negative 7x. 7 times x is 7x. And 7 times negative 7 is negative 49. So this is going to simplify to x squared minus 7x plus 7x minus 49. However, negative 7x and 7x cancel out, and we're left with x squared minus 49. And our last one is 3x minus 5 times 3x plus 5. This is going to be 3x times my second binomial of 3x plus 5 and negative 5 times my second binomial of 3x plus 5. 3x times 3x is 9x squared. 3x times 5 is positive 15x. Negative 5 times 3x is negative 15x. And negative 5 times 5 is negative 25. Well, again, 15x minus 15x cancel out, and we're left with 9x squared minus 25. For each rectangle below, determine the perimeter and the area. The area should be written as a trinomial. So we know that perimeter is the length around a rectangle, and the area is the area that covers it up. So for perimeter, we're going to have to add our four sides together. We know that this side is 2x plus 5. We know this side is 3x minus 2. So our perimeter is going to be 2x plus 5 plus 2x plus 5 plus 3x minus 2 plus 3x minus 2. If we add these together, 2x plus 2x plus 3x plus 3x is 10x, and 5 plus 5 is 10, minus 2 is 8, minus 2 is 6. So our perimeter is going to be 10x plus 6. Our area as a trinomial is going to be our length times our width. Well, our length is going to be 3x minus 2. Our width is going to be 2x plus 5. So if we multiply these out, we can make our little box. I'm going to run out of space here, sorry. 3x minus 2, 2x plus 5. 3x times 2x is 6x. 3x times 5 is 15x. Negative 2 times 2x is negative 4x. And negative 2 times 5 is negative 10. Well, this simplifies into 6x. 15x minus 4x is 11x. Sorry, this is 3x times 2x is 6x squared. So 6x squared plus 11x minus 10. For our next problem, 45, we have a square. So 7x minus 3, 7x minus 3 is the length on all four sides. So our perimeter is going to be 7x minus 3 plus 7x minus 3 plus 7x minus 3 plus 7x minus 3. Or you could do 4 times 7x minus 3, which is 28x and negative 12. Either way, you're going to get 28x minus 12. Our area is going to be 7x minus 3 times 7x minus 3. 7x times 7x is 49x squared. 7x times negative 3 is negative 21x. 7x times negative 3 is negative 21x. And negative 3 times negative 3 is positive 9. So this is going to simplify to 49x squared minus 42x, because negative 21x plus negative 21x is negative 42x plus 9. Next, we've got a bunch of factoring problems. 46 says x squared minus 8x minus 20. So when A is 1, we're looking for what multiplies to C, which is negative 20, but adds to B, which is negative 8. Negative 20, that's 1 and negative 20. We could do negative 1 and 20, but we know that that's going to be too far apart. 2 and negative 10. Well, 2 and negative 10 is negative 8 when you add them together. This is negative 19. So I really can stop there, and I know that these are my factors. So it's going to factor into x plus 2 times x minus 10. Another way to look at this is A is 1, C is negative 20. So 1 times negative 20 is negative 20. I'm looking for what multiplies to negative 20 but adds to negative 8, which we see is 2 and negative 10. And then I could put all of my terms into my box. Now this is me starting with the trinomial. So my first term, x squared, is going to go in my first box, and negative 20, my last term, is going to go into my last box. Now I'm getting negative 20 from this, not from this. They happen to be the same because A is 1. But you'll see later when we do 51 and 52 how that kind of changes, or 50. So then I'm going to fill in my other two boxes with my two terms that I found. So 2x and negative 10x. And then I'm going to take the GCFs. Since I do it with my x squared in the bottom, I'm going to be going up and going this way. So what do I mean by that? Well, if I look up, x squared and 2x, what is the GCF? Well, the largest number that can come out is 1, and the largest variable is x. Looking this way, negative 10x and negative 20. When the first term in the box is negative, I can pull out a negative. The largest number that I can pull out of both is 10, and there's no variable. Next, I'm going to go this way. The largest number I can pull out is 1, and I'm going to pull out a positive 1 because the first term is positive, and the largest variable I can pull out is an x. Finally, I'm going to go this way. The largest number I can pull out is a 2, positive 2, and there's no variable I can pull out. Same way, this is going to give me x plus 2 times x minus 10, which is what I got here. So this is a much easier way, but this way applies for all problems like when we get to number 50. My next one is x squared plus 16x plus 60. So I'm going to look at what multiplies to 60 but adds to 16. Well, I know they're both going to be positive since this term is positive. So I'll start listing my factors. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 1 plus 60 is 61, 30 plus 2 is 32, 20 plus 3 is 23, 15 plus 4 is 19, 12 plus 5 is 17, and 6 plus 10 is 16. Well, I want what adds to 16, so my factors are going to be 6 and 10. So it's going to be x plus 6 times x plus 10. And those are my factors. My next one is a little bit harder. X squared minus 36. Now I could do factors of negative 36 that add to 0, but there also is a shortcut. When a squared minus b squared factors, it factors into a plus b times a minus b. This is how that middle bx term gets canceled out. So when we see the difference of binomials, we have to look at what squares minus what squares to equal x squared minus 36. Well, what squares to get x squared? X. And what squares to get 36? 6. So A is x, b is 6, and this factors into x plus 6 times x minus 6. So my answer is x plus 6 times x minus 6. My next one is x squared minus 121. Same thing. What squares to give me x squared? What squares to give me 121? Well, x squares to give me x squared, and 11 squared gives me 121. So this factors into x plus 11 times x minus 11, and that is my answer. All right, number 50. This says 3x squared minus 5x minus 2. The first thing you should always look for is to see if there's a GCF. Is there a number that can be taken out of all three of these? Well, 3, 5, or negative 5 and negative 2 are all prime numbers, so there is no GCF. So we're going to do this the way I did this second part up here. And because A is not 1, we need to multiply A times C. So 3 times negative 2 is negative 6. And I'm going to look for factors of negative 6 that add up to negative 5, my B. Well, we have 1 and negative 6. We have negative 1 and 6. 2 and negative 3. Negative 2 and 3. 1 and negative 6 is, 1 and negative 6 is negative 5. Negative 1 and 6 is 5. 2 and negative 3 is negative 1. 3 and negative 2 is positive 1. Since I want it to add to negative 5, I'm going to use these. But it doesn't work the same way. It's not as simple as when A is 1. So I'm going to make a box, and I'm going to fill in my box with my givens. So my first given is I'm going to always use my first term and my last term. So I'm going to put in 3x squared and negative 2. Do not put negative 6 in there. You will get it wrong. Then I'm going to fill in my other two boxes with my two factors, 1x and negative 6x. Finally, I'm going to take the GCF of each column, working from the bottom up, and each row working from left to right. This way, if the first term that comes in there is a negative, I'm going to pull out the negative. 3x squared and 1x. There's no GCF that's a number, but there is an x that can be taken out of both. For negative 6x and negative 2, I can take out a negative, and my largest number that I can take out is 2, but there's no variable. For my rows, 3x squared and negative 6x, my GCF is a 3, and I can take out an x. And for my top row, my GCF is a 1, and there's no variable. Therefore, this factors into 3x plus 1 times x minus 2. 51. 2x squared minus 10x minus 12. Remember that I just said the first thing you need to do is look for a GCF. It will make these problems easier every time. Well, 2, negative 10, and negative 12 are all even numbers. So if I have 2x squared minus 10x minus 12, I can factor out a 2, and I'm left with x squared minus 5x minus 6. Now I need to factor this, but it's so much easier because A is 1. So negative 6, we've got 1 and negative 6, negative 1 and 6. Well, 1 and negative 6 is negative 5. 6 and negative 1 is 5. Sorry, I should put equal signs here because I'm adding them. I'm looking for what gives me negative 5, so I want 1 and negative 6. So this becomes 2. Don't lose the 2. X plus 1 times x minus 6. So my final answer is going to be 2 times x plus 1 times x minus 6. My final one is negative 3x squared minus 21x minus 36. First and foremost, if a is ever a negative, pull out that negative. This leaves us with 3x squared plus 21x plus 36. Next, I can look to see if there's a GCF. Please always remember to look for a GCF first. It's the easiest way to get your complete final answer. Well, I notice that 3 goes into all of these. So I can pull out a 3, and I'm left with x squared plus 7x plus 12. Finally, I can factor this trinomial much easier by doing what multiplies to 12 but adds to 7. 1 and 12, 2 and 6, 3 and 4. Well, 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. I want 7, so my factors are going to be x plus 3 times x plus 4. And so my final answer is going to be negative 3 times x plus 3 times x plus 4. And this will give us our completely factored trinomial. And that ends our review for Unit 4, Topic 2, questions 38 through 52.